Sound is the vibration of air perceived by our ears. Healthy ears can perceive sound waves of frequencies from about 20 to 20,000 hertz. This range will become narrower due to aging or noise exposure. Sound waves create signals in the inner ear, which are transmitted to the auditory cortex by the cochlear nerve and auditory pathway. The sense of sound is produced in the auditory cortex. Sound waves are directed into the external auditory canal by the auricle. Sound waves cause the eardrum, which closes the auditory canal, to vibrate. The vibration of the eardrum is transmitted to the cochlea by the ossicles, the hammer, the anvil, and the stirrup. The base of the stirrup fits snugly into the oval window of the cochlea. The basilar membrane is located inside the cochlea. It runs along the tip of the cochlea, where it turns back and continues in Reissner's membrane. The membranes divide the cochlea longitudinally into three cavities: the scala tympani, the scala media, and the scala vestibuli. The cochlea is filled with a fluid, which is vibrated by the stirrup. Higher frequency sounds cause vibrations of higher frequency in the liquid, which are absorbed in the initial section of the membrane. Lower frequency vibrations generated by deep sounds enter the cochlea and become absorbed closer to the tip. When a vibration is absorbed, an electrical signal is produced, which is transmitted into the brain. The pitch of the sound is encoded by the site of absorption. This is called tonotopy. Electrical signals are generated in the organ of Corti. Vibrations spreading inside the cochlea push the tectorial membrane against the hair cells found on the basilar membrane and bend them, generating a signal in the cells. Thus, the organ of Corti transforms vibrations into electrical signals, which are transmitted into the brain by the cochlear nerve, and then into the auditory cortex by the auditory pathway. Finally, the sense of sound is produced in the cerebral cortex.